Guided exercise number 3. An explosion caused by methane gas blew a manhole cover vertically into the air. The height of the manhole cover t seconds after the explosion was s equals 36t minus 16t squared feet. Part A says determine the acceleration of the manhole cover at time t. So to do this, we have to get the velocity first. The velocity is going to be 36 minus 32t. And then the acceleration is going to be the derivative of the velocity, which is negative 32. And by the way, the units here, velocity is feet per second, and the acceleration is feet per second squared. And so you'll recognize that number as the acceleration due to gravity. Part B says, when was the manhole cover traveling in the positive direction and then the negative direction? So for this, we have to figure out when the manhole cover is stationary. So it's stationary when V is equal to 0. So 36 minus 32t equals 0. So 36 is equal to 32t. So t is equal to 36 over 32. Divide by 4, that's 9/8 of a second. So the manhole cover is stationary at time 9/8 of a second. And so we can make a chart. So 0 to 9/8, because again, we only care about positive, or maybe you could make a case for 0 times. We don't care about negative times. And then 9/8 to, I'm going to be a little cagey here and put impact. Because if you think about what's going on with the model here, the model is going to break down when the manhole cover hits the ground. And in a later part of this problem, we will actually figure out the time of impact. And so we'll just leave that there as a placeholder for now. And we'll do what we did on the last problem. So we'll plug something into the velocity. We'll work out the sign of the velocity. And then we'll say the direction of travel, the direction of motion. So from 0 to 9/8, I'm definitely going to plug in 1. So I'm going to work out the velocity at 1, which is 36 minus 32, which is 4. And then from 9/8 to impact, I'm just going to plug in 2. So velocity at 2 is going to be 36 minus 32 times 2, okay, which is negative 28. So my sign of the velocity is positive here, it's negative there. My direction of travel is positive direction and then negative direction, which makes sense when you think about the model. If the manhole cover is blown off, it's going to go up and then it's going to come back down and it's going to land. So again, that impact that's in quotes there is TBD, the impact time. And when we get it, we'll double check and make sure that 2 seconds does actually fall within the correct interval. Part C, so let's make a note to go back. Let's put a big star here. Part C says, when did the manhole cover reach its maximum height? Try to do this 2 ways, using Part B and without using calculus at all. So based on Part B, the particle or the manhole cover is traveling in the positive direction and then the negative direction. And so the manhole cover is going to go up and then down. So its max height will occur at the time when it's stationary, which is 9/8 of a second. So the max height is, oh, we don't care what the max height is. Never mind. How could I tell? The when. So the maximum height has to be at t equals 9/8 of a second from Part B. Or using pre-calculus, It's going to happen at the vertex of the parabola. So you don't actually have to use calculus to do this part. The vertex of the parabola is negative b over 2a, which is negative 36 over 2 times negative 16, which also works out to be 9/8 of a second. So either way, the manhole cover reaches its maximum height at 9/8 of a second. And I anticipated my next question because part D says, how high did the manhole cover go? So we know that the maximum height was reached at 9/8 of a second. So if we want to know how high the manhole cover went, we have to take that 9/8 of a second and plug it in to our height function. So S equals 36t minus 16t squared. Plug in 9/8. So 36 times 9/8 minus 16 9/8 quantity squared. And it really doesn't matter what that works out to be. Whatever it is the maximum height. The units there are feet. And I plugged this into a calculator, and it works out to be exactly 20.25, so 0.25 feet. And by the way, this is an exact decimal answer. I did not round to get this. Exact, did not round. So if you get a whole bunch of decimal places, more often than not, it's because your calculator is rounding, and it's better to keep the answer exact. But this is an exact decimal answer, and so I'll keep it. Part E says, what was the velocity of the manhole cover when it struck the ground? Well, we don't know when it struck the ground, and so that's the first thing that we'll have to figure out is when did the manhole cover hit the ground? So the position function was S equals 36t minus 16t squared. And so if we want to know when the manhole cover struck the ground, we want to know when that position function gives us a 0, because that represents ground level. So 0 equals 36t minus 16t squared. Factor out a t times 36 minus 16t. So t equals 0. The manhole cover is on the ground, but that's the start time. And then 36 minus 16t equals 0. So 36 equals 16t. 36 over 16 is equal to t. And you could simplify that if you want to. It's 9/4. So, important, our manhole cover hits the ground at 9/4 of a second, which is slightly more than 2 seconds. So our chart in the previous part was okay. But let's finish this question before we go back and add this little bit of detail. So at time 9/4 of a second, the manhole cover hits the ground. And we want to know the velocity at that time. So the velocity at 9/4 of a second is going to be 36 minus 32 times 9/4. And that actually works out to be negative 36, and it's feet per second. All right, so now let's go back to our direction of motion part. Let's go find that. The manhole cover hits the ground at time 9/4 of a second. So at time 9/4 of a second, there it is, part B. So this impact time here is 9/4 of a second. And we plugged in 2, which is slightly less than 9/4, and so our chart is still fine. When you plug in a value, you have to make sure that it's actually falling in the correct time interval. But time 2 is in the correct time interval, so everything was fine.